In this lesson, we are going to learn how to determine the molar mass of an element and compound. When we look at the molar mass, what we're talking about is the mole of a substance. So when we have 6.022 times 10 to the 23rd atoms or molecules of a particular substance. So when we're talking about an element, we look at the mass of 1 mole of atoms of that element. That simply means we have 6.022 times 10 to the 23rd. Having the molar mass is useful because it helps us figure out how much of a substance we need in terms of grams, which is something that's easy to measure with a balance. So if we look at boron, for example, what we see is that the molar mass is 10.806 grams per mole. So if we had 6.022 times 10 to the 23rd atoms of boron, it would have a mass of 10.806 grams. For fluorine, we see that it would have a mass of 18.998 grams per mole. Notice that the units are grams per mole, and this is an important thing to remember because when we start doing calculations using molar masses, we're going to need those units in there to be correct. So we always have grams over moles. We looked at the molar masses of these two elements. Now we're going to look at the molar mass of a compound that's composed of both boron and fluorine. Here we see we have the compound Bf3, and we know we have 1 boron, so we take 1 times 10.806 grams per mole, and we have 3 fluorines, so we take 3 times 18.998 grams per mole. So we've accounted for all of the atoms in our molecule. Now we add that up and we get 67.800 grams per mole for Bf3. What this tells us is if we had 1 mole of molecules, 6.022 times 10 to the 23rd molecules, it would have a mass of 67.800 grams. Sometimes we'll hear the term molecular mass instead of molar mass. While these two values both have the same number, they have different units and a different meaning associated with them. The molecular mass is the mass of 1 molecule of water. So if we were able to isolate a single molecule of water, it would have a mass of 18.02 AMU. Remember that AMU stands for atomic mass unit, and it has a very small mass, about 1.6 times 10 to the minus 27 kilograms each. Molar mass is looking at 1 mole of water molecules, so we have 6.022 times 10 to the 23rd water molecules, which has a molar mass of 18.02 grams per mole. Same number, different units, different meaning. Let's look at an example. What is the molar mass of Al2SO4 Remember what we learned about interpreting a chemical formula and what those subscripts tell us? So we have 2 moles of aluminum, so 2 times 26.982 grams per mole. Each unit has 3 sulfurs, so we say 3 times 32.066 grams per mole. And then we have 12 oxygens, because remember there's a 4 inside the parentheses. The 3 outside goes with everything inside the parentheses. So 12 oxygens times 15.999 grams per mole. And when we add them all up, we end up with 342.15 grams per mole. So 1 mole of aluminum sulfate units would have a mass of 342.15 grams.